Hello and welcome. We continue our SD-WAN Architecture Matters series, and in today's session, Steve Wu will demystify the differences between SD-WAN, SDN, NFV, and VNF. Steve Wu is a VP of Product and co-founder here at VeloCloud. Before we start, a couple of housekeeping items. This webinar is being recorded, and you will get a link to the recording shortly after the session. The presentation slides, as well as other resources, can be found by clicking the Attachments button in your interface. We hope to have time at the end for Q&A, although this presentation is very technical and quite involved. So we have reserved some time, but please send your questions in as early as possible. And now, welcome, Steve.
Thanks, Sasha, and welcome to another in our Architecture Matters series. That sound like a mouthful of acronyms, so we'll try to dig through that today. I'm presenting live from Orlando. This is just following the Gartner Symposium, where this was an interesting topic. So the goal today is we'll take a broader look at how SD-WAN relates to the principles of both SDN and NFV, as well as software-defined networking and network functions virtualization. So First, I'll start off by looking at how the SDN architectural principles, really more importantly, the market goals that drove those, have been applied, taking it from a more data-centric application to applying it to the WAN and implementations for a next-generation WAN in terms of SD-WAN. Okay. So on this slide, let me start first with what is SDN. And so the ONF, or the Open Networking Foundation, has been really the forum or the leader in defining the SDN architecture. And a key principle in this architecture was the separation of the control plane from the forwarding plane. Really, the goal, what was more important, was to increase programmability and also to allow the abstraction of application flows and network services on the underlying infrastructure. So through the course of this webinar, we'll see how that actually can be applied or transformed to the problem we're trying to solve in the WAN side. But really, the direct programmability was to enable this abstraction, as well as what everyone wants to do is increase the agility to really adjust network-wide traffic flow to meet the changing needs. The goal of central management is key to really get a global view on the network and to simplify configuration changes. Programmatic interface or configuration, obviously the goal of that is to let network managers more easily configure, manage, and optimize the network resources, and also particularly for service providers to do this via automated software programs as well. And obviously as the different market segments mature, to move these towards open standards, both for simplifying design in terms of putting different pieces together and also allowing interoperability between vendors. So let's see how SDN, or the principles of SDN architecture, be applied to an SD-WAN implementations. Are really going from data center to the WAN and going from an architecture principle to an actual implementation. So before I actually launch into the table, I think as this has evolved, the higher level goals and customer expectations are really for, number one, simplified and centralized management. So the central management, putting control into software. So part of the split on the control over data plane was to put control on the software, so that software can be rapidly innovated, and with an API that allows programmatic inputs, and then ultimately with the software hardware split, or the control plane data plane split, to enable the use of more cost-effective commodity hardware, and also have more interchangeability between the hardware components. So quickly touching on the highlights of this table. So while SDN decouples very strictly decouples control and forwarding elements, the SD-WAN really takes a more hybrid approach to this. So local decisions will be made with local context, but based on centralized control policies. See the importance of that later and why this applies to the internet and the WAN as opposed to more of a data center centric deployment. The goal of agility is achieved based on adjusting the forwarding to meet policy, as well as, and this is a key new requirement for SD-WAN, as well as real-time transport or link conditions. And so this enables application flows independent of the underlying infrastructure, i.e. the transport. And then in most part, most SD-WAN implementations are software-based, and some are even network as a service, such as what's offered by VeloCloud and our provider partners, so that also allows for rapid innovation. And then obviously central management is available via central policy and orchestration. It can all be programmed via a REST API. So in the WAN world, it's not yet standardized, as it is in for OpenFlow, but there is work underway in multiple forums, including ONUG, which is actually meeting next week, and MEF coming up shortly in November as well, to start to talk about SD-WAN interoperability. But already the software approach of SD-WAN has already allowed the use of off-the-shelf x86-based hardware. Actually, on the next slide, let's look at evolving real-world expectations of SD-WAN. And this is captured by one leading analyst group, Gartner. So they basically defined SD-WAN as having four, critical components. So one is that it's a lightweight, that's a key word, the lightweight replacement for traditional complex routers. Obviously, the goal is to simplify the branch WAN edge. It will be the WAN edge device, particularly at the branch, not necessarily at the data center. The critical new functionality is the ability to leverage multiple WAN connections and do this under unified policy, and also bring this or abstract this up to an application level and make that independent of the underlying transport. And then overall, it's discussed with SDN, simplify the complexity of traditional WANs. This goes hand in hand with the goal of increasing agility. And then finally, they do expect secure connectivity and additional network services. So this is where we'll later see that NFV should be a more flexible and powerful way to deliver these additional network services, as opposed to a more traditional way to do that. So going on to the next slide, let's expand actually beyond the goals that Gartner set for SD-WAN. But first, let's recap what an SD-WAN solution is. So in this diagram, it's not just a CPE replacement, but really is an end-to-end solution. It's a logical overlay network. As we mentioned, the key is it can encompass any WAN transport. So a mix of private MPLS, public, internet, broadband, even LTE. Could be independent of the service provider or encompass multiple providers. It works between any two SD-WAN nodes. In this diagram, the nodes deployed at branches and data centers are called edges. And key to the SDN approach, these edges can be software. The cloud-delivered implementation would also extend this overlay to any cloud, POP, or data center with the use of what we call multi-tenanted cloud gateways. So really the key additional benefits on the bottom. Right, the first benefit, as Gartner mentioned, is simplifying the management of WANs. And this is especially important as enterprise IT wants to use multiple circuits instead of a single circuit, or multiple providers. We also want to keep the simplification as we insert additional services, and that's where the NFV play comes in. Next benefit, to take it further than the Gartner definition, is really to assure the performance of critical applications. Really focus on performance, not just using multiple types of links, to assure the performance of the apps, even as you add different links. And more advanced solutions can achieve this even if they're using internet-only links. And finally, I think the extended or stretch goal is that some more advanced solutions should support the enterprise migration of their apps and data and services to the cloud. So the goal of a cloud-delivered solution would provide all the same benefits that you have within an enterprise all the way to any cloud destination as well. So in this next slide, I won't touch in too much detail. I'll just expand a bit on the architecture for an SD-WAN solution. So in addition to the edges for the on-premise deployment and the gateways for the cloud access deployment I mentioned in the previous slide, I just wanted to highlight there are also at the top of this slide distributed redundant policy controllers. And we'll get into the function of that further, as well as the management interface or orchestrator for viewing and configuring policies. For a cloud-delivered service or a managed SD-WAN service, these can all be hosted in the cloud as a service. And quickly on the data plane, I think we covered this, but the edges obviously can leverage both public and private circuits as available. They can connect to other edges, so multiple edges in data centers, as well as to different gateways for different cloud SaaS or infrastructure as a service destinations. And a branch edge can also dynamically connect to other branch edges for direct branch-to-branch traffic. That's the architecture. Let me touch on some of the key features of SD-WAN to meet the requirements that I spoke of from both Gartner and our extended goals as well. So on this slide, the key to both simplifying WAN management as well as assuring app performance is dependent on three critical functions. So the first is this to automatically and continuously monitor or profile every link that's plugged into the overlay. Then based on the link performance to steer critical apps, important apps to the best link at that moment in time. More advanced solutions can also do this on a per packet, not flow basis. And what this means is a flow can be moved, like a phone call midstream, without dropping the session or even the end user noticing, as well as for high bandwidth applications to aggregate the link capacity for a single session. And then to also have on-demand remediation. It's needed if you have only a single link available, or in the case that both links have degradation at the same time. You want to do actual error correction, jitter buffering, and fast retransmission. So the end benefit of this approach is not assume nor depend on the quality or the SLA of the individual links, but basically to use the overlay to engineer and assure the app performance. So in the GUI snippet on the left-hand side, good example. The bottom will show the underlying link performance of multiple links. One is a private MPLS link, one is a cable broadband link. Obviously green is good, red is bad, and gray is actually disconnected or down. So in this, and then the top bar shows the overlay resulting app performance. In this case, we're looking at how a voice application would work. And basically, the example here is if there's degradation or outage detected in the private link, and this is where solutions that pin critical traffic to assuming the SLA of the private link, there could still be a cable cut on that. You want to dynamically move the traffic to the second broadband cable link. But if you have degradation on that one, then you have to also call in on-demand remediation to fix that problem. But the end result everyone's looking for is great application performance. That was on the assured app performance. As we mentioned, the second or the other key benefit of SD-WAN that we're looking for is simplification. There are many ways that SD-WAN can simplify. I'll just cover four of the top functions that are delivered to simplify the WAN. So first, it provides centralized provisioning, and that was a basic tenet of SDN. So to really help reduce the touch for branch deployments, use group profiles. They're all abstracted to the application level. In this case, many solutions can also do smart defaults. The automatic link discovery automates the configuration, so you don't have site-by-site configuration, even though each site has a different link setup. And this also can all be hosted in the cloud for further simplification, or installed on-premise if you desire. Another good example on the right of simplified configuration is building that secure connectivity that Gartner mentioned. So branch to data center VPN from on-site device to on-premise device to on-premise devices. Normally easy as expected, but as more and more infrastructure the services used, such as Amazon or Azure, you end up with an end branch by end data center manual two-sided VPN tunnel configuration, dependent on the actual IP addresses of both ends. It becomes very complex. So one advantage of having a cloud gateway is it can still provide the consolidated dual-ended connection from all the branches automatically to that gateway without having to backhaul and without having to do manual tunnels to connect to your cloud destinations. Third use case for simplifying the WAN is for service insertion. So if you backhaul internet traffic to an on-premise service, SD-WAN makes it easy to actually distribute or deploy services to multiple mini regional scrubbing centers or even to the cloud, but without complex node-by-node routing to try to forward traffic at a course level. Right, so basically, app-aware policies can actually do this at an application level, and we'll see how this capability fits naturally into supporting the NFV capability to dynamically push services to different locations. So it goes hand in hand with that functionality. And finally, in addition to selecting links, an SD-WAN solution can simplify the overall end-to-end routing. Right, so network routes are automatically learned from all the SD-WAN overlay edge devices, talking to the legacy network on the branch and the data center or even the cloud side via standard routing, whether it's OSPF or BGP. But we'll see this in the architecture. But the visibility control is simplified because we have central management or an enterprise-wide consolidation of this route information. That was also one of the principles of SDN, was to really bring in some form of central management. And once we have that central consolidation of the routing or control policy, as this is presented to the orchestrator, then we can also make one-click changes to that and redistribute it out to the multiple SD-WAN nodes, not on a node-by-node CLI configuration basis. And finally, as I mentioned earlier, the last extended goal, I think, for SD-WAN, because that's also a goal, I think, for definitely NFV as well, is to support migration of services to the cloud. And this shows you the typical problem on the left is legacy or even other SD-WAN architectures don't easily support migration to the cloud. And for cloud access, either you have to backhaul the traffic across the private WAN or the device-to-device WAN, or if you do a direct breakout from the branch, since there is no SD-WAN node on the other side in the cloud, it becomes best effort. The goal of a cloud-delivered solution, such as the one that VeloCloud delivers, is to extend all the same SD-WAN benefits you have from an on-premise site to an on-premise site, and extend that directly to the cloud, with the ability to pre-install gateways at all the major cloud data centers and services. That's something both VeloCloud does, and you've seen the announcements that have gone out over the past several weeks. Our large service provider partners are deploying in the cloud and at the access to their private cloud networks as well. with the, so I covered the SD-WAN benefits, goals, the architecture that supports that. Now that I've covered that and the components, let me come back to the SDN principle of separation of the control plane and really cover how that fits in. So I think for the, it achieves the goal of easier reprogramming, right, multi-vendor interoperability, and I think for a lot of cloud providers, allowing the use of cheaper switches. But since the deployments were in large data centers at a provider or an enterprise, or typically the controllers were co-located with the data plane switches, this architecture works. However, if you look at the traditional architecture for internet scale network, it does have a distributed control plane. Right? Basically, the benefit of that is it's highly redundant. You have no single point of failure. It's highly scalable. But the corresponding drawback is that there was no holistic view of the network control, so it was very complex to implement end-to-end policies and changes, or if you wanted to really take an application flow point of view and program that across a network, that was fairly complex. If we look at the SD-WAN approach, I think the goal and the and what the solutions can deliver is really a best of both worlds approach. The architecture implemented for SD-WAN had to take into account the distributed nature of the WAN, so no longer limited to nodes in a single data center or campus. So in fact, the best implementation has a distributed control plane. So you see the control and data is at the different SD-WAN nodes, so forwarding decisions can be made locally based on policy, as well as there's local knowledge of the real-time link or circuit conditions. Right, so there is no latency or failure issues caused by an inability to reach a remote control. Yet each SD-WAN edge also communicates to multiple centralized but redundant control policy controllers. So it can get centralized control policies, get its relevant information. This also provides for enterprise-wide visibility up to the management interface to view it, and also easy programmability for the management interface to configure and push new policies down to the entire SD-WAN infrastructure. Let me take a look at a bit more detail on this on the next slide. I can forward that. So as I was showing, the edges can get centralized control policies from the controllers. And these are configured and viewed from the orchestrator management application. In this example, on the upper right, you can see there's an enterprise-wide overlay flow control table that shows just a little snippet, all the reachability for all the subnets across different paths, the preferences for that. So this is important because the SD-WAN is an overlay. So the edge-to-edge overlay tunnel information is distributed via the controllers to the different edge nodes, not hop by hop through the network peers. But additionally, at the branch edge or the data center hub edge or in the gateway, we learn the routing from the legacy network, so it's interoperable with the legacy networks. So we get that routing information from the peers. This is actually then consolidated via the controllers, which is viewable and then configurable from the orchestrator, and then actually it's redistributed to all the other endpoints or exit points of the SD-WAN overlay. And for cloud deployments, these controllers, controller function is typically co-resident with where the cloud gateways might be deployed. For enterprise solutions, they could be deployed on premises as well. But the bottom line of this architecture is that it simplifies the routing. You have that central view that everyone's going for, but it maintains the advantages of local forwarding control. Which brings us to the million-dollar question, I think, which we were asked many times. I think when SD-WAN was first first hitting the marketplace based on the SDN principles was, okay, gee, if will data plane traffic be negatively impacted if obviously something happens to that control plane? So the questions became, is there any impact to my data plane traffic if there's a failure of a controller, perhaps because it's installed on-premise and it was not installed redundantly, or if there's a loss of connection to an orchestrator, particularly if I'm using a hosted cloud-based orchestrator, maybe the link, maybe the internet link to the cloud is down, but I still want my private VPN to be working, or perhaps the controllers are too far away. If I'm using a hosted controller, does the latency between the edge and hosted controller also impact the speed of my data flows? Obviously, the correct answer, of course, is none of the above. That's a key point, and that's a key design criteria for SD-WAN that departed a little bit from the very strict SDN principle separating the control from the forwarding, is that it had to be distributed to basically meet these market requirements. So local control, local knowledge of link conditions means that data flow continues without the controllers. All forwarding decisions can be made locally, automatically adjust for link performance brownouts. This also means there's more flexibility in deploying the controllers and orchestrators remotely. They could be hosted in the cloud as a service. Obviously, if an orchestrator is not reachable, right, the redundant controllers will continue to redistribute learned routes. The only thing that would be impacted if the orchestrator is currently not reachable is the ability to configure new end-to-end policies. That would be temporarily offline, or could be configured in the master database, but would not be updated throughout the SD-WAN network until the reachability is reconnected. But bottom line, a very, very robust, very redundant system. Now let's, that was how SD-WAN related to the principles of SDN. Now in this next section, I want to look at actually both what NFV and VNF are, and then how that relates to SD-WAN. On this slide, first let me just cover how NFV and VNF are related. So a little bit of history. NFV was created by a consortium of service providers called ETSI. NFV, go back and explain. NFV is Network Functions Virtualization. VNF are the virtualized network functions. So they're very closely related. So many network services, from routing to firewalls and even SD-WAN, can be virtualized for easy deployment. NFV basically refers to both the infrastructure or platform on which these VNFs can run, as well as the management and orchestration layer that can oversee the multiple VNFs on this infrastructure. So this is much more than just having a virtual software instance of a different function available, and I'll talk more about this progression or spectrum of offerings available. The infrastructure layer has both a software as well as a hardware resources layer. In the past, much of the NFV has been focused on the data center, whether it's been deployed by providers or enterprises. But the interest is that it holds huge potential for simplifying deployment across the WAN, because in the WAN we have lots and lots of branches where we might want to more simply distribute services. So in the next slide, let me just quickly review the benefits that the NFV brings to service delivery, and as we go through this, you'll see parallels to the business goals that we have for SD-WAN as well in terms of WAN connectivity, right? So first and foremost, as a goal was to quickly roll out new services and locations. And given that, it becomes easier to efficiently distribute these services to needed locations. So you can see the tie to branches, right? Because now we have more and more locations that we might want to virtually deliver services to. Obviously, multiple VNFs can also reduce the set of appliances or the required, or open up the choice of hardware. This also simplifies all aspects of operations, procurement to training, to sparing. Capacity can also be easily scaled up and down. And then virtual lifecycle management reduces downtime. So if you have a function that went down or you need an upgrade, virtual as opposed to an appliance deployment simplifies this as well. So it's very easy if you look at all these benefits to see how the objectives are very complementary, and whether you're applying them to network services or to the WAN in particular. On the next slide, let's, as I've hinted at, SD-WAN and NFV are very complementary solutions. They're not the same, but they're very complementary. Any solutions that have both capabilities are extremely powerful, so there is some area of overlap. So let me just talk about three key aspects or sort of use cases where SD-WAN and NFV make such a strong combination and make so much sense. And so basically, NFV, you dynamically create services. You can put them in different locations. SD-WAN, as I mentioned earlier, can provide agile connectivity as well as the policy-based service chaining to get the traffic to the right locations where the services are offered. Those two capabilities go hand in hand. Obviously, the primary goal of SD-WAN is to simplify branch deployment. After you get the basic connectivity deployed to the branch, the next thing that will come into question is, oh, I want to deploy additional services at the branch. How can I simplify that as well? NFV provides the architecture to simplify the insertion of virtual network functions at the branch as well. And then finally, in the past, NFV, especially as used by providers, has really helped to move more services to the cloud, thin out the branch virtualized services. And hand in hand, you need next generation WAN that can optimize and simplify access to cloud-hosted services as opposed to traditional on-premise services. So all these things go hand in hand, makes for a really powerful combination. So let's on the next slide, let's look at actually how closely SD-WAN can actually support the whole concept of NFV. So I'll start from the left-hand side. All right, so one advantage, obviously, of software-based SD-WAN is programmability, and even better is the hardware independence. All right, so there are solutions that, obviously, software, they may use proprietary hardware. Most solutions actually have more independence by leveraging commercially available, commercial off-the-shelf hardware or white box hardware. You'll find many vendors still pre-package it because it provides the convenience and of combining the software with the hardware and also optimizing the configuration of the hardware for the particular branch deployment. So next on the scale is offering SD-WAN as a virtual machine image, supporting the key hypervisors, and basically simplifies the portability across different hardware platforms and configurations. However, neither of these two things on the left don't really offer the true simplification of multiple virtual service delivery. NFV is more than just having or supporting your typical hypervisor. On the right-hand side is true SD-WAN plus NFV. So the capabilities you'd have to include would be, how do I do zero-touch deployment, bootstrapping, licensing of the services, authentication? How do I service chain among the multiple services that are deployed on the same platform? How do I troubleshoot problems that might arise? How do I do the lifecycle management of the different VNFs? And then also, obviously, how do I support the APIs to provide the SDN programmability to other systems? So the two real combinations of SD-WAN and NFV are the implementations on the right-hand side. So the first one is a layer 3 virtualized SD-WAN CPE. This is basically an SD-WAN-based platform that has native SD-WAN capability. So it's something that will be offered by an SD-WAN solution provider such as VeloCloud, but it includes the ability to insert additional and most likely selected virtual services. And so, but it includes that, again, to achieve the goal of distributing services easily to the branch. Then further to the right, you have a general purpose NFV infrastructure management orchestration platform, so meant to really deploy all services, not even necessarily related to SD-WAN itself. SD-WAN could just be one of the services on that. But the two right-hand side deployments are in fact true NFV type deployments that can support SD-WAN. On the next slide, the concept that I want to highlight is in looking at the implementations and keeping with the spirit of SDN, the ability to offer choice and an open platform is very important. So if we just look at that aspect, right, on the very left-hand side, you might have an NFV solution that could provide NFV benefits, but it's primarily for VNFs that come from the same and the single NFV vendor, and simply having directly competing VNF services, while technically may not, from a business point of view, may limit such a platform's ability to offer additional best-of-breed choices and partnerships. In the middle is the example of a more open approach, and this is in fact the approach VeloCloud is taking. It will offer NFV capabilities tied in obviously with its own SD-WAN solution, but for a very selected set of network services that are most relevant for branch deployments. And this is where it's different from a general purpose NFV that can also handle the data center side as well. So most relevant for branch deployments such as firewalls, but the target would be to have an open platform, a non-competing platform that enables delivery of best-of-breed partners for the selected NFV of interest in the enterprises, such as firewalls. And on the right-hand side, an example of a general-purpose NFV platform. All right, these are actually now being packaged for the market by service providers as virtual CPEs, and this can actually offer best-of-breed choices for all the services, including for the SD-WAN service. As an SD-WAN solution provider, the advanced providers, and VeloCloud does this, need to provide the APIs for their SD-WAN VNF for easy integration and orchestration by a general-purpose NFV platform. So, covered a lot of different concepts in talking about SD-WAN, SDN, and NFV. But in summary, hopefully, as you have seen, these three things share very similar principles and objectives, but they have slightly different applications and slightly different implementations. The bottom line, the solutions are highly complementary, and there's some overlap between them, and any combination of functionalities across these three spheres are very, very powerful. And I think the real commonality is the end benefit or goal, which is agility. I think that's top of the list. Reduce cost, availability or redundancy, interoperability among multiple systems to allow open choice, and to also really support the corresponding move to software and to the cloud. And then these apply for all, given these three technologies, really then applies to all aspects of the end-to-end network and services as well. Given that that's the end of my prepared slides, hopefully that has given a good intro and overview to these three different technologies and how they relate to each other. And let me turn it back to Sasha, because I think we'll have time for some questions.
Thank you, Steve. We have quite a few questions, so let's jump right in. Just a quick reminder to the audience that the recording will be available within an hour after the session is over, and then you can download the slides from the attachment sections in your interface. Click on Attachments tab, and you'll see the link to the slides. So with that, we're going to start on the questions. So Steve, first question, how would you assure performance for an additional VNF inserted into an SD-WAN edge that offers NFV capability?
All right, so when this actually goes to market, the NFV-ready version of the platforms would have options for different CPE devices, and they would typically include additional cores that are necessary for the sizing required by the specific VNFs that are added to that. Basically, a VNF-ready SD-WAN edge, for example, would typically have more cores to support the additional functionality that would be virtually instantiated.
All right. If performance and security can be achieved over internet links, what benefit would there be to using SD-WAN over MPLS?
Right. So the number one benefit actually was the unified provisioning and the ability to move application flows independently across multiple links. So in fact, one of the typical and ideal deployments is if there's an existing an MPLS link to use SD-WAN to add an internet link or take a backup internet link and bring it as an active resource into the virtual WAN bundle, and then to, based on policy, business priority, and also link conditions, move traffic across the appropriate link. I think I mentioned previously in that example I showed, might have degradation on the broadband link, and you might want to move traffic back to the private link, or you might have a fiber cut on the private link and move traffic back and forth. Really, the benefits of SD-WAN in terms of the programmability, the transfer independence apply across any type of links, and in fact, the more different and diverse type of links, as well as providers that you want to use, simplification value becomes even greater.
All right, thank you. On to the next question. How is the edge configured to work with an existing customer-provided firewall?
So basically, there are many different deployments, but the typical recommendation is the SD-WAN edge would be on the WAN side of the firewall, because basically the SD-WAN would typically also do the VPN encryption as well, so we want to make sure the firewall has full visibility before putting the traffic into the SD-WAN tunnels. That would also give the easiest setup for the SD-WAN to allocate traffic across the different links. And while some of these SD-WAN solutions will have built-in firewall capability, even for the native services, these are all virtualized on-off options. So if you're using an external firewall, you would just turn off the internal firewall capabilities to make sure there's no conflict.
All right. Next question. Given that SD-WAN can do load balancing across multiple links based on app traffic and other parameters, will SD-WAN make WAN optimization technology obsolete?
So I think it's a middle ground. It certainly reduces the requirement for new deployments of WAN optimization, because in fact in the past WAN optimization was used for legacy apps, also running deployed on premise, running across long distance, and running across high quality but limited bandwidth connections. But a lot of those issues are going away. The one issue that SD-WAN solves is by allowing the use of broadband connections to bring in economical bandwidth. So the deduplication compression is no longer required. The ability to go directly to a cloud location, as well as the distribution of applications from a central enterprise location out to the cloud, automatically reduce the potential latency that a user has to face to get to his deployed application. So basically the ability to use broadband and the internet and actually to go straight to cloud applications, it reduces a lot of the problems that WAN optimization used to be used to solve. But there's some cases where it would still fit for sort of a legacy type of app and circuit deployment.
All right. Just a quick reminder to our audience that we were hoping to wrap up the webinar about 10 minutes to the top of the hour, but given how many questions we're receiving, we'll probably stay on until 11 a.m. Pacific. So if we don't get to your questions live, we will answer them via email following the webinar. So keep sending them in, and let's see what Steve can do. Okay. So, Steve, next question is if you could provide your opinion on this. So the question is, we've heard some SD-WAN providers tout SD-WAN as a replacement for MPLS VPN. My opinion is that it's not a replacement, but rather an enhancement. What are your thoughts?
Absolutely, I think that's the way to approach it. Right? It really is an enhancement. You can add public links, you can add LTE, you can add diversity of types of circuits, but to maintain that diversity, MPLS is one of those diverse types that have certain characteristics that are good. The other thing that we should distinguish, and that's very critical, is between use for the last mile access loop versus what's used for the mid-mile or the backbone. So we obviously think there's tremendous use for hybrid on the last mile, which would be an MPLS plus a broadband link for last mile. There's obviously use cases that we see from enterprises for completely over the top for the last mile. So one single broadband, dual broadband, in fact even dual LTE for mobile sites. But actually with the introduction of the managed SD-WAN solutions from different service providers, the other benefit is it could be hybrid from off-net to on-net. In that case, you can use actually hybrid links for the last mile or even over-the-top internet only for the last mile. But if you have a gateway deployed at the cloud access to the MPLS port, and internet traffic for the last mile, that's the only thing available, can still hop onto the private mid-mile or backbone for a long-distance SLA guaranteed journey, for example. They really go hand in hand very well.
And next question, I actually have two questions that are very similar. Let me read off both, Stephen. Maybe you can combine your answer. So the first question is, if the on-ramp is via broadband access or LTE, how do you assure the performance? And the other question was, how do you assure performance over internet?
All right, so that's similar. So basically, it's we haven't really coined the market really hasn't coined a standard term yet, but it's more engineered performance as opposed to contractual business SLA performance. And we basically do that most optimally by having multiple diverse types of links. As I mentioned, it's assured via the link steering. So assuming because I can measure the link condition out of the multiple links, I can choose one link versus another. And then in addition, if I only have one link or both links happen to have a problem at the same time, which actually does not happen that often, you've chosen diverse providers as well as types of links. And then we can do the remediation that can still cover for packet loss as well as jitter problems. And then the path selection can help with latency in case there's a hotspot across some internet peering point as well. Obviously, if you have multiple links and there's two fiber links and both fiber lines are cut by a backhaul, then nothing will help you in that case.
All right. Next question. Is the traffic encrypted between edges regardless of link type? For example, internet, MPLS?
On that one, I can't answer in general, but I'll answer for the VelaCloud solution. So it's a policy decision. So one option or advantage is someone can have then unified secure communications, same end-to-end encryption across any link, even over a private MPLS for additional security, or by application or by link, they can choose not to use encryption based on either the link or application as well. We have all those policy-driven options to sort of adhering to the programmability thought in an SDN type solution.
All right, so next question. How many and where are VeloCloud gateways located? Do the edges go to the nearest gateway? Can I control security at the gateways?
So we have gateways distributed at all the major cloud data centers. Just slightly under 40 locations worldwide. For example, in the U.S., there are already 10 primary locations. The edges will connect to the gateway that's best optimized for the destination. So, for example, a single edge and a single branch might connect to the nearest gateway because the Salesforce application or the Skype for Business is located nearby the branch, and we'll use the nearest gateway that's actually to that destination. If that edge is also connecting to a gateway for a tunnel connection to a legacy data site via interoperable VPN tunnel, then that edge would connect to a gateway that's closest to that legacy enterprise data center. That's the answer. And I'm not sure about the question on security. So obviously, we control the encryption. We can control the handoff, the VLANs. We do not have a built-in firewall, for example, at the gateway. That's really a function of the NFV services that will be offered by the provider hosting the SD-WAN as well as other security solutions in the cloud.
All right, we have time for a couple more questions, so I'll just go on. How do you provide connectivity from a premise to a cloud service that requires a layer 2 Ethernet interface?
So our solution is a layer 3 overlay. So it's not a layer 2 device as a virtual CPE for a branch.
Next question, is there a specific virtual CPE you work with, or do you provide one?
On the, there's two definitions on the virtual CPE. So for the, when I'm talking about the NFV approach, if it's our SD-WAN platform, we will provide the underlying NFV software infrastructure as well as the hardware, and we source our hardware from multiple providers. Or if it's our SD-WAN solution as a VNF for deployment on a more general purpose NFV platform. For example, the AT&T announced a managed SD-WAN service with VeloCloud, and they're offering something called AT&T FlexWare, which is their universal CPE. I have a couple of different flavors on that. So they deliver the virtual CPU is delivered by our service provider partner along with the orchestration.
All right, next question. You mentioned that link stats were locally available to make forwarding decisions. Can I get a centralized view as well?
Oh yes, no, absolutely. So on the one hand, it's very important to have those link stats available at the local edges, so the forwarding decisions can be made without any latency, without having to have a connection to the remote controller or orchestrator. On the other side, we do absolutely flow all these stats up to the orchestrator for a nice centralized view. So a centralized IT administrator can easily troubleshoot down to an individual branch, down to the individual links in a multi-link setup, and figure out quickly what's going on. So absolutely.
All right. Next question. Does Office 365 Software as a Service use VeloCloud services?
So basically goes back to the gateway question. So we are deployed at all the major cloud data centers. So I believe we'll find that we are either in the exact same facility or definitely within the metro, and that's the key, is to be in the same metro and the same very low latency between our gateway handoff and the target cloud application.
All right. So we have time for a couple more questions. I know they're still coming in. We will try to get to as many as possible live, but we also want to be sensitive of time. And so if your question doesn't get answered, we will email you with the answer. Next question is, how many WAN links are supported?
So this depends on the different platforms. So we have a variety of platforms in our portfolio. I think that information should be available on our website, but on the lowest end we'll have 2 gigabit Ethernet ports. We'll have 1 or more SFP ports that can support fiber interfaces, for example, and then USB ports that will support LTE modems. On the larger boxes, we'll have a larger number of direct GIGI Ethernet interfaces for WAN links. It really depends on the configuration of the platform.
Okay, 2 more questions. Number 1, are there REST APIs to programmatically control SD-WAN?
Oh yeah, so absolutely. I mentioned the key aspect of SDN, and in VeloCloud's case, we actually do already have multiple providers that are using our REST APIs to integrate, and actually 2 different use cases, both to their NFV platform orchestration, as well as directly to their operational backends, actually bypassing our management GUI interface.
All right, we have a couple minutes left. So, Steve, there's a question here that might require some time to answer, but I'm going to ask it anyway. Can you give a real-world use case of SD-WAN service chaining to NFV deployed services?
I think that's a great question. Actually, as reference, I believe I covered that in our service chaining webinar, so there would be a slide in that deck, but let me just try to walk through that use case. So sure, in the past there were many services such as firewall security that were centralized in a single enterprise data center. So then the downside of that is all the traffic had to be backhauled. With NFV, it becomes much simpler to distribute the security services either to multiple enterprise regional security centers or many regional data centers, or actually over to the cloud as well. So without having SD-WAN, you'd have very coarse and then complicated routing updates you would need to do on a branch-by-branch router for hundreds of branches or thousands to get traffic from different branches to different distributor locations, as opposed to one central location. SD-WAN, application-level policy, enterprise-wide profiles can really simplify service chaining to send traffic from a branch to many different locations where NFV might have populated a firewall or other security service. So really that capability goes hand in hand with making an NFV distribution of services practical from a network configuration point of view. Very good question, thanks.
All right, we're going to have to wrap up. There's still plenty of questions that left unanswered. We apologize, but we're just out of time. Quick note, Steve is going to be presenting another webinar on December 1st. So please join. He's going to be tackling application performance. Anyway, thank you so much for joining, listening, and interacting with us. Steve, thank you for the presentation, and we'll see everyone next time.
Hey, thanks everyone for joining. Thank you.